Okay, so let's talk. Welcome back to normal. Yay, normal. Um, so we're officially done with AI tests, thank goodness. And we should have our results back. I would guess we'll have the EOC results back in a couple weeks. So in a couple weeks, we should find out the EOC scores. Everything else comes the week after that. The other stuff won't come until the last week of school, or it'll come after y'all get out for the summer. So, sorry. I don't think for the most part any of you are overly concerned with the dollar to some of it. So, some of y'all finished in like 15 minutes, which is fun. So anyway, so back to normal. So we have our geometry unit. The geometry unit is a unit that we created here a couple years ago based off of geometric concepts that we would like to teach you rather than have your next teacher teach you. I guess is the easiest way to say it. So it's not like we're teaching you the first 2 weeks of geometry. That's not the way it is. If you look at your schedule, we have regions formed by lines today. On Monday and Tuesday, we have simplifying radicals days 1 and 2, which are a little bit like an amped up version of what you already know. That's something that we use throughout geometry, all the way through front to back. Pythagorean theorem days 1 and 2. That's, I think, like second unit of geometry, maybe third unit of geometry. So you'll already kind of have a heads up on that. Trigonometric ratios are also like the third unit of geometry. Trigonometry, or a better way to say it is trigonometric ratios, is simply an application of right triangles that we teach everyone else. We want to make sure that we teach that to you. And then radicals mixed practice, then you have an exam. Now, if you look also on May the 25th and 30th, now here's the problem. May the 25th is actually 8th grade celebration day. So the exam will not start on May the 25th because I will not be here. The 8th graders will not be here. Y'all will basically have a chill day, whatever. 7th graders. 8th graders, y'all will be going to main event and acting a fool. So that's the 4-day weekend. So we're off Friday, Saturday, Sunday, Monday. Friday is the second snow day that we didn't use, obviously, and Monday is Memorial Day. Then we come back and we go to school Tuesday, Wednesday, Thursday. Y'all exam Tuesday, Wednesday. It's an end of semester exam. Remember, this is where the high schools get exam scheduled, so they get like 2.5 hours to take it. Y'all do not, so we have to split it into half, so it's half one day, half the next. And then that Thursday, the last day of school, we are doing nothing. The only thing that's really going on that day is the annual, incredibly famous Smith speech, and that's really it. Okay? And that's where I cry out my interview. So, what? It's a very sad day for me, so shut up, don't. We will avoid talking about the last day of school for a long time. Y'all can think about it, y'all can celebrate in your head, but do not bring it up in front of me because for me it's very sad. So, okay? Any questions? I'll look at you. All right, so here we go. So let's talk about geometry. Anyone know what geometry is? It's basically shapes. If you were to break down algebra, guys, algebra, in its simplest terms, algebra would simply be a math that studies the relationship between x's and y's. Studies the relationship between x's and y's, right? Geometry is the study of math within and around shapes. Because many shapes, for many shapes, there are multiple mathematical relationships. And you're going to get into what those mathematical relationships are in circles and triangles and rectangles and trapezoids and rhombi and all these different shapes. You're going to do these things called proofs, which suck no matter, I don't care who you are. There's not a single person I've ever found in my entire life that likes proofs. Ever. Miss Earl just likes proofs, but she's an anomaly. She's like complete math dork. It's like complete math dork. So if you ever find anyone that likes proofs, run away from them. Yeah, because they're weird. Okay? So we're going to talk today about regions formed by lines. So let me kind of give you an example. If I were to say I would like you to graph these lines. Y equals negative 2x minus 3. Y equals, while I'm doing this, go snag the calculator real quick. Y equals 2x plus 31. Y equals 11. And y equals 3. Now, if I were to ask you to graph these lines, that's what it's called. I would ask you to graph these lines. Where would you start? Let's just call lines 1, 2, 3, and 4. Someone tell me how you would start to graph line 1, please. Joey? Okay. Negative 3 on the y-axis, and then where to from there? Down 2 over 1, down 2 over 1, down 2 over 1, right? Might help to go up 2 and backwards. And then once you get that, then, and by the way, before I allowed you to not necessarily draw a straight line, that is not the case anymore. You will draw a straight line with a ruler or a protractor, okay? And then you're simply going to connect the dots. It's a little bit harder with this thing, so we'll just go with that, okay? So this represents the line approximately y equals negative 2x plus 1. Let me extend this up. Make sure I'm going to stay on the line. Everyone agree with that? Cool. Who wants to tell me how to graph line 2? Pardon? But I don't have a 31 on my graph. So that's not a valid way to do it. Perfect. I can go to my calculator and do what? I can enter in y equals 2x plus 31 in my calculator. I can go to the table, look on the XY table, and find graphable points. Someone give me some graphable points or ordered pairs from the table for the line y equals 2x plus 31. Kristen? Okay, Avery? Negative 10. Right. Negative 10 positive.
Oh, yeah.
Okay, because I was going to say that's a problem. Negative 10, positive 11. Let me, okay. Some others? I need at least 3 or 4. Go ahead, Madison. Negative 11 and 9, which is right here. By the way, once I have 2 points, what could I now do? Slope, right? Well, I'm going to just use the slope. What's the slope? The slope is 2. So once I have a couple of points, I can just go up 2 over 1. Up 2 over 1, down 2 over 1, down 2 over 1, right? And then, bam, I have my line. So exactly the same process. I get my handy whatever this thing is, and I draw my line. Now I have to manipulate this a little bit because this is not as easy to do electronically as it will be with, there. Okay, good to go? Starting to get vertices. What are vertices? The pointy things. And then Joey is doing the thing where you make a steeple and all the people and, okay, so whatever that is. A vertex is basically a corner. It's the intersection of 2 lines. Now, who wants to tell me how to graph my next 2 lines? Start with number 3. I want to graph line 3. Someone tell me how you graph this line right here. Pardon? Okay. It's a horizontal line at 11. I told you you're going to have to remember that. It is a horizontal line at 11. That is the line y equals 11. And how do I graph the line y equals 3? Same thing at 3. So it's another horizontal line at 3. Now, I have 4 lines on the board. If you look at all their points of intersection, could you write the ordered pairs for every vertex? guess? Someone give me one of my vertices. -3, +3. And let's do this dude is at -7, 11. Ooh, -7, 11. Oh, okay. What? Yeah. Flipping. Okay, so here we have -10, -10, and 11. And our final vertex right here is at -14 and 3. Please make sure you put your X's and the Y's in the right order. Y'all are now basically high school geometry students. Do not mess up the order pairs or be prepared for lots of me making fun of you. Any questions on this? Any questions on how to graph the lines, find the vertices? What? Let me ask you a question, Joey. In a system, 2 lines, how many solutions are there? There are 0 or either 0 solutions, 1 solution, or infinitely many solutions. So if you're asking me if those lines are going to intersect somewhere else, my answer would be no, silly. Okay, then how do you get another vertex?
So that's like, how to do black ones, like right there.
Oh yeah. What I'm getting at, I see what you're saying. What I'm getting at is that if you were to color in the shape of all 4 intersecting lines, you have that. Which means you have a what? You have a trapezoid. Could you find the area of a trapezoid?
If I had a formula.
Oh, very good. And if you look on the 6th or 7th grade formula sheets, you'll find the area for a trapezoid. Somehow you forgot that, our little high school geometry students. By the way, the formula for the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. Every quadrilateral in the world is basically base times height. Base times height. The only one with trapezoid has 2 bases that are different lengths, so you have to base 1 plus base 2 divided by 2 times the height. Any questions on that? One more. What is it as well? Okay, so here we go. Y equals 2/3 x plus 4. Y equals -1/3 x minus 5. And x equals 3. Who wants the first line, and which one do you want to graph? Andrew. Give me ordered pairs, but don't try to connect them because I've seen your straight lines. So just give me ordered pairs. Which one are you choosing, by the way? X equals 3. He chose x equals 3. That's the one I would have chosen. I'm making fun of him. I would have chosen that. Because we know that every line that's x equals looks like what? Vertical line. The vertical line. Thank you, Andrew. Now you're just showing off. So we have a line x equals 3, which basically is a straight line, and bam! Yeah, a little bit. Who wants the next line? Go ahead, Steve. You don't have to give me 18 ordered pairs this time. I just want to make sure it was all the ordered pairs you needed. Perfect. Thank you. All right. So she started the y-intercept with -5, and then she went down 1 over 3, which gave us this line right here, right? Gave us this line right here. Let me slide it down just a little bit. So we're on a roll. Last line. So who hasn't done it so far? Don't make me just call your name randomly. Kate Norton, get up there. Yeah, Kate's like, don't even look at him. Don't even look near him. I want this line graph. Where would you start to graph that line? Wood. And there's a reason I want you to do this, and then we'll get into your classwork homework, because the classwork homework should go very, very quickly. Okay? Thank you, buddy. You're good. Appreciate it. Very good. Okay, so he graphed it. He went to the y-intercept. He went up to over 3, which is perfect. And now we're going to connect all these dots, and we end up with this line, right? By the way, a couple things. Make sure that your lines have a little arrow you guys at the end, because they do go on and on. Now, the intersection of these 3 lines creates a what? Creates a triangle. So we say, okay, so here's a triangle right here. We shade it in, so Mr. Smith knows, I know exactly where that thing is. Could you identify the vertices of this triangle? Yes, just where they intersect. What if I said I would like for you, in addition to finding the vertices, I would like to know what the area of this triangle is?
Oh, that's thin.
Okay, so, okay, I'll take that. Base times height. Now, which one's which?
Oh,
The base
what?
is the vertical line.
Okay, so Madison says she wants to use the base as the vertical line. And then what is the height?
We can just count below squares.
Count the little squares, what? Just count squares?
Yeah, all the squares inside.
What do we know about the base and the height of any shape? They must be perpendicular to one another.
So it's the,
And it has to go, yes, and it has to go to the highest point. So basically we know that if this is the base, then this has to be the highest point. Agreed? So you draw a line that is perpendicular to the base, and this will be your height. And then you use the formula for a triangle, which is the area equals 1/2 base times height, and we start counting. Now, if you'll remember back, I said when you're counting steps, you never start counting until you are moving, right? So if I'm counting these, it goes from here, like I'm going to start right here, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 1/2 and the base is 14. And the height, I would do the exact same way. I would start right here, and I would count 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. 14. And then I can pick up my handy dandy notebook and do 1/2 times 14 times 14, which is 98. By the way, units squared. Be amazed if I did that in my head. You know how I did it? What's 1/2 times 14? What's 7 times 14? Not that impressive. I always take the 1/2 times an even number and it creates a smaller number, and then I just multiply that number forward. But this is what you're doing today. Now, I want you to do classwork and homework. I want you to get through the classwork. The homework is 1 page, 1 side only. It will take you no time at all. It is the official, you look on your calendar, it's the last homework you will have this year. So, do your classwork, do your homework, holler if you need help, and remember, if you ask for, I don't have inside voices. If you ask for help, be prepared for me to make fun of you, because all you do is tracking lines, shading shapes, and finding the areas. Go.